Good morning, students. Today we start next topic, most important compounds of nitrogen. First we discuss most important compound, that is ammonia. Its formula is NH3. Its formula is NH3. So ammonia is present in small quantity in air as well as in soil by the decay of nitrogenous organic matter, for example urea. So we used fertilizer urea to enhance the crop production and quantity or yield of crops. So also we used to provide the proper quantity of nutrients to the crop, so that is decomposed when it react with water to form ammonium carbonate salt, and there is a reversible reaction, production of ammonia along with water and carbon dioxide. So in this way, the small amount present of ammonia in case of air as well as in soil, it have pungent smell. So let us discuss how can we prepare in labs and on industrial scale, on large scale, because it is a most starting material for the production of maximum compounds. So let us start. First we prepare in labs. How can we prepare ammonia on a small level in a laboratory preparation? So we prepare from ammonium salts. We prepare from ammonium salts of with the strong alkalis like caustic soda or lime water. So when we react ammonium chloride with lime water, it will give ammonia plus water plus calcium chloride. When we react ammonium sulfate or ammonium chloride with sodium hydroxide, it will give ammonia 2 molecule along with water along with sodium sulfate ppt. So in these two reactions we can prepare ammonia from the ammonium salts with the reaction of alkalis or caustic soda or lime water. Also we prepare with the help of magnesium nitride, react with water to form a milk of magnesia along with the water ammonia. So when how can we dry the ammonia? When we pass over a quicklime, calcium oxide act as a dehydrating agent for मॉइस्चराइज्ड अमोनिया, क्योंकि कितना कितने साढ़े को वाटर वेपर्स प्रेजेंट होते हैं. सो इस करके डिहाइड्रेटिंग एजेंट वी यूज कैल्शियम ऑक्साइड. वी डजंट यूज dehydrating agent like a concentrated sulfuric acid, phosphorus pentaoxide or anhydrous calcium chloride, because ammonia react with these compound to form the salts or a complex. So we can dry ammonia by passing over a quicklime. Why we use calcium oxide or quicklime for drying the ammonia? We used only because it acts as a dehydrating agent for ammonia, but we cannot use concentrated sulfuric acid P2O5 or calcium chloride because it reacts with these three components to produce their salt as well as a complex. So that's why we cannot use concentrated sulfuric acid, ammonia, phosphorus pentaoxide or calcium chloride for the drying of ammonia. We people only use calcium oxide or quicklime. Clear? So next, how can we prepare ammonia on industrial scale? So the process name is by Haber process. So when we react 1 molecule of nitrogen and 3 molecule of hydrogen, this reaction is reversible in nature and it will give 2 molecules of ammonia. So a 2 molecule production of ammonia, there will be a release of enthalpy, because this reaction is an exothermic reaction. So the enthalpy of formation, that is equal to minus 92.2 kilojoule per mole for 2 molecule. If we calculate for 1 molecule, half of this enthalpy, that is minus 46.1 kilojoule per mole. Let us discuss the full-fledged explanation of this process. There are three main conditions required for the preparation of ammonia on industrial level. First, we required low temperature. Forward reaction is an exothermic reaction, so it means a minimum temperature or an optimum temperature required of about 700 Kelvin is necessary, which we provide with the help of electricity. So we heat the particular reaction with the help of electricity to attain a optimum temperature. Next, high pressure required for the reaction between nitrogen and hydrogen gas according to Le-Chatelier principle. So 200 atmosphere or into 200 into 10 per 5 Pascal pressure is required for the reaction between nitrogen and hydrogen gas. Third one is presence of catalyst iron oxide with a small amount of molybdenum or potassium oxide or alumina as a promoter. So ਸਾਡੇ को molybdenum act as a प्रमोटर कितना कितने साडे को जड़ा एनहांस दी एक्टिविटी ऑफ कैटालिस्ट सो कैटालिस्ट नूं साडे को होर रेट ऑफ रिएक्शन नूं इंक्रीज कर लिए यूज़ किया जाता सो लेट अस डिस्कस दी फ्लो चार्ट डायग्राम ऑफ Haber process so we people use 3 molecules of hydrogen and 1 molecule of nitrogen passes through 3:1 of these two gases passes through the pipes and put into the compressor where 200 atmospheric pressure present here so when we compress these two gases after compression we pass through a lime tower because it's free from moisture and carbon dioxide so then we fill it with the catalyst chamber it fill in a catalyst chamber where iron oxide potassium oxide or alumina is present so in these presence of catalyst the nitrogen and hydrogen gas react with on the surface of these catalysts so we also provide electrical heating to this catalyst chamber or we heat this catalyst chamber to enhance the rate of reaction so up to 700 Kelvin we only first time heat this catalyst chamber for further reaction we cannot heat because this process is an exothermic so that heat released during the reaction that is utilized for further purpose so catalyst chamber तो बाद कितना कितने साडे को नाइट्रोजन ते हाइड्रोजन ऑलमोस्ट 20% ਜਿਹੜੀ ਰਿਐਕਟ ਕਰਕੇ ਅਮੋਨੀਆ ਫਾਰਮ ਹੋ ਜਾਂਦਾ ਬਾਕੀ ਸਾਡੇ ਕੋਲ ਨਾਈਟ੍ਰੋਜਨ ਤੇ ਹਾਈਡਰੋਜਨ ਗੈਸ ਥਰੂ ਅ ਕੰਡੈਂਸਿੰਗ ਪਾਈਪ ਸਾਡੇ ਕੋਲ ਪਹੁੰਚਦੀਆਂ ਨੇ ਤੇ ਸਪਾਇਰਲ ਹੋਣ ਕਰਕੇ ਜਿਹਦੇ ਕਰਕੇ ਕੂਲ ਹੁੰਦੀ ਹੈ ਕੂਲ ਹੋਣ ਕਰਕੇ ਸਾਡੇ ਕੋਲ ਲਿਕੁਇਡ ਅਮੋਨੀਆ ਦੇ ਵਿੱਚ ਚੇਂਜ ਹੋ ਜਾਂਦੀ ਹੈ ਤੇ ਅਨਰਿਐਕਟਿਵ ਨਾਈਟ੍ਰੋਜਨ ਤੇ ਹਾਈਡਰੋਜਨ ਗੈਸ ਦੁਬਾਰਾ ਫਿਰ ਅਸੀਂ ਕੰਡੈਂਸਿੰਗ ਪਾਈਪ ਦੇ ਥਰੂ ਫਿਰ ਪੰਪ ਦੇ ਵਿੱਚ ਦੀ ਭੇਜਦੇ ਉੱਥੋਂ ਕੰਪਰੈਸ ਹੋ ਕੇ ਫਿਰ ਦੁਬਾਰਾ ਸਾਡੇ ਕੋਲ ਕੈਟਾਲਿਸਟ ਚੈਂਬਰ ਦੇ ਵਿੱਚ ਕਿਤੇ ਨਾ ਕਿਤੇ ਪਹੁੰਚਦੀਆਂ ਨੇ ਜਿਹਦੇ ਥਰੂ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀ ਹੈਗੀ ਆ ਉਹ ਜਿਹੜੀ ਗੈਸ ਆ ਉਹ ਇੱਥੇ ਤੱਕ ਪਹੁੰਚਦੀ ਹੈ ਕਲੀਅਰ ਸੋ ਇਸ ਵੇ ਦੇ ਨਾਲ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀ ਹੈਗੀ ਆ ਉਹ ਰਿਐਕਸ਼ਨ ਜਿਹੜੀ ਹੈਗੀ ਆ ਹੁੰਦੀ ਹੈ ਪ੍ਰੋਸੀਡ ਸੋ ਦੁਬਾਰਾ ਫਿਰ ਸਾਡੇ ਕੋਲ ਕੈਟਾਲਿਸਟ ਚੈਂਬਰ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਪ੍ਰੋਸੈਸ ਹੈ ਕੰਟੀਨਿਊਸਲੀ ਸਾਡੇ ਕੋਲ ਚੱਲਦਾ ਰਹਿੰਦਾ ਕਲੀਅਰ ਸੋ ਇਨ ਦਿਸ ਵੇ ਵੀ ਕੈਨ ਪ੍ਰਿਪੇਅਰ ਅਮੋਨੀਆ ਔਨ ਇੰਡਸਟਰੀਅਲ ਸਕੇਲ ਕਲੀਅਰ ਸੋ 3:1 ਦੇ ਵਿੱਚ ਅਸੀਂ ਦੋਨੋਂ ਗੈਸਸ ਫਿਲ ਕੀਤੀਆਂ ਕੰਪਰੈਸ਼ਰ ਦੇ ਵਿੱਚ ਉਹਨੂੰ ਪ੍ਰੈਸ਼ਰਾਈਜ਼ਡ ਕੀਤਾ ਕੂਲ ਕੀਤਾ 200 ਐਟਮੋਸਫੀਅਰ ਪ੍ਰੈਸ਼ਰ ਤੱਕ ਉਹਨੂੰ ਲਾਈਮ ਵਾਟਰ ਦੇ ਵਿੱਚ ਦੀ ਪਾਸ ਆਊਟ ਕੀਤਾ ਤਾਂ ਕਿ ਉਹਨੂੰ ਡੀਹਾਈਡਰੇਟ ਕੀਤਾ ਜਾਵੇ ਕਾਰਬਨ ਡਾਈਆਕਸਾਈਡ ਤੋਂ ਫ੍ਰੀ ਕੀਤਾ ਜਾਵੇ ਫਰਦਰ ਕੈਟਾਲਿਸਟ ਚੈਂਬਰ ਦੇ ਵਿੱਚ ਪਾਸ ਕੀਤਾ ਜਿੱਥੇ ਉਹ ਸਾਡੇ ਕੋਲ ਸਰਫੇਸ ਪ੍ਰੋਵਾਈਡ ਕਰਦੇ ਆ ਕੈਟਾਲਿਸਟ ਇਨਹਾਂਸ ਕਰਦੇ ਆ ਰੇਟ ਆਫ ਰਿਐਕਸ਼ਨ ਜਿਹਦੇ ਕਰਕੇ ਨਾਈਟ੍ਰੋਜਨ ਤੇ ਹਾਈਡਰੋਜਨ ਦੇ ਇਨ ਬਿਟਵੀਨ ਐਟਮਸ ਦੇ ਮੋਲੀਕੂਲ ਵੀਕ ਹੁੰਦੇ ਨੇ ਫਰਦਰ ਦੇ ਰਿਐਕਟ ਵਿਦ ਈਚ ਅਦਰ ਐਂਡ we also provide optimum temperature 700 Kelvin which is required for the proceeding of reaction so through the condensing pipe ammonia will be condensed or cool and change into liquid ammonia and the remaining unreactive gases nitrogen or hydrogen passes through the pipes and pump and further pumping them into again pass through the catalyst chamber and for this process continuously proceed clear. Next we discuss what is the structure of ammonia. We already discussed structure of ammonia. The configuration of nitrogen is 2s2 2p3 so there are 3 electron required to 3 electron have to share with hydrogen atom so one electron from one s from each hydrogen share with overlap with 2p orbital so according to this hybridization it has sp3 hybridization and its shape according to this it is tetrahedral but due to presence of lone pair its structure is trigonal pyramidal or you simply say pyramidal structure and you know that HNH bond is 107.8 degree clear and its bond length is 101.7 picometer between NH and so next first we discuss the physical properties of ammonia so it is a colorless gas with pungent smell boiling point 239.7 Kelvin and melting point 198.4 Kelvin it is a lighter weight than air so highly soluble in water why it is highly soluble in water due to formation of hydrogen bonding that's why they are highly soluble in water and easily liquefy so next we discuss the chemical properties of nitrogen so first one is basic in nature when we react with ammonia with water it will give ammonium ion and hydroxide ion it acts as a weak base when we put red litmus paper in ammonia, it changes into blue in color. It means it acts as a weakly basic in nature, so because it produces hydroxide ion in aqueous solution. Next, it acts as a Lewis base. Due to presence of lone pair, it donates lone pair to form a complex compound. For example, when copper sulfate, which is a color blue in color, when react with ammonia, aqueous solution of ammonia, it will give complex with copper, because availability of orbitals in case of copper, in that orbital this ammonia give the electron pair into that empty orbital of copper, so its color becomes change into deep blue. ਇੱਥੇ ਸਾਡੇ ਕੋਲ light blue ਹੁੰਦਾ, but ਇੱਥੇ ਸਾਡੇ ਕੋਲ deep blue ਹੁੰਦਾ, which indicate ammonia bonded with copper ion. So silver react with chloride ion to form a silver chloride white PPT. When we react these white PPT with ammonia, it again form a colorless complex with ammonia. Clear? So in this way it have tendency to donate electron pair to form a complex compound. So it means it acts as a Lewis base. So next property is that is oxidation. So ammonia is oxidized to dinitrogen with oxidizing agent like a cupric oxide, sodium hypochlorite, or calcium bleaching powder. So for example, when ammonia is passed or heated with copper oxide with ammonia, it will form copper metal along with nitrogen or hydrogen. So copper oxide to copper metal ਨੂੰ reduce ਕਰ ਲਈ ਸਾਡੇ ਕੋਲ use ਕੀਤਾ ਜਾਂਦਾ ਕਿਤੇ ਨਾ ਕਿਤੇ oxidizing agent ਦੇ ਨਾਲ, ਜਿਵੇਂ ਕਾਪਰ ਆਕਸਾਈਡ ਹੋ ਗਿਆ ਉਹਦੇ ਤੋਂ ਸਾਡੇ ਕੋਲ ਕਾਪਰ ਮਿਲਦੀ ਹੈ। ਉਸੇ ਤਰ੍ਹਾਂ when ammonia react with oxygen with air in the presence of platinum, and at this temperature it will give 4 molecule of nitric oxide, which this reaction is used for the preparation of nitric acid in post-Wall process. So it is an important reaction for the preparation of nitric acid. So it is also combustible in nature, but it is not a spotter of combustion or not a combustible substance, but it burns in the presence of oxygen to form dihydrogen gas. So now along with water vapors. So when ammonia react with oxygen, upon heating with oxygen, it will decompose into nitrogen along with the water vapors. Next, formation of amide. So when we react sodium metal with ammonia at this temperature, it will form sodamide along with the liberation of hydrogen gas. So what are the uses of ammonia? It is used to produce various compounds like a fertilizer, ammonium phosphate, ammonium sulfate, ammonium phosphate, urea. So it also used for the preparation of nitric acid or sodium carbonate. It is used as a refrigerant. It is used in the manufacturing of rayon polymer. It is an important reagent and also used as a solvent in laboratories. It is also used for preparing a various nitrogenous fertilizers. So this is your most important compound of nitrogen, that is ammonia. If you have any doubt in case of preparation, structure, physical or chemical properties, you can contact me or do the reaction very carefully, even balanced reaction, because for the examination point of view, sometimes complete the reaction and balance. So complete the reaction on the properly balance honi chahiye. Clear? So in this way, so if you have any doubt in this topic, you can contact me. Thank you.